All right, in today's lesson, we're going to move on from two-step probability into more than two steps, or two or more steps. And to do that, we're going to look at things called tree diagrams. So our learning intentions are to understand how tree diagrams are used to list the sample space for experiments with two or more steps, and to be able to construct a tree diagram to show all possible outcomes and find the probability of events. So first one is understanding, the second one is doing. All right, so let's move on. We've got this example here where it says you are offered a choice of two pieces of fruit from a banana, an apple and an orange. You choose two at random. The tree diagram shows selection with replacement. So remember from last lesson we had replacement being available where you could possibly choose two bananas or two apples or two oranges. So we have the tree diagram shown here. So we first start from left. We could choose banana, apple, orange. Once we've made that choice, we're now sitting here, so we could be at banana and choose banana, apple, or orange, or we could be at apple and choose banana, apple, or orange, and so on for orange, like this. All right, so the way to read it is we read it across. So the first interesting thing is outcomes. So we can look at, we have this outcome here, which is banana, banana. We have this outcome here, which is banana, apple. This outcome here, which is banana, orange. Then we'd have apple, banana. We'd have apple, apple. We'd have apple, orange. We'd have orange, banana. We'd have orange, apple, or orange, orange. All right, so you can see that we read tree diagrams across the page like this, but we count up the results down the final column. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 results. 9 outcomes. All right, how many outcomes contain two round fruits? So this relies on our knowledge of what a fruit looks like or what particular fruit looks like. So anything with a banana is discounted because a banana is not round. So we can cross out all of those. We can cross out apple banana and orange banana. So we have 1, 2, 3, 4. 4 outcomes. And then the last one says, how would the tree diagram change if the selection was completed without replacement? Would there be any different in the answers to the above two questions? All right, so how would the tree diagram change if the selection was completed without replacement? Which probably makes more sense in this context because the idea is that if I'd chosen banana first, it wouldn't be available for second choices. So we can cross off double fruit choices. All right, so now I haven't got 9 outcomes. I have 9 minus 3, which is 6 outcomes. All right, so that would obviously affect the first question. There wouldn't be a total of 9 outcomes, there'd be a total of 6. However, would it have affected the 4 outcomes in question 2, where you can see here that yes, it would have, because I wouldn't have chosen that one, and I wouldn't have chosen that one. So now the question says there are 2 round fruits. There would only be 2 choices out of the 6 for round fruits, because the only 2 choices available are apple orange or orange apple, being the round fruits. So we're going to look now at how to make them. Before we do that, here is an overview of the key ideas in them. All right, so we've got here, tree diagrams are used to list the sample space. So you saw the sample space being down the final column here, all possible outcomes. The outcomes are listed vertically, and each stage is connected with branches. So the branches are these blue lines, and they go across. The outcomes go down. Okay, so with replacement is when you can have the same result multiple times. Without replacement is when once you have that result, it's no longer available for choice. So if I chose A the first time, I couldn't choose A the second time, it's only B or C. Okay, so tree diagrams, in my opinion, are one of the more simple things to draw. All right, so let's have a look at drawing one. So we've got an experiment involves tossing 2 coins. All right, so 2 coins. So I can have 2 branches, head or tail. All right, complete a tree diagram to show all possible outcomes. Now, I've just realized head or tail, that's the first coin. The reason we use a tree diagram is because I now have to flip the second coin. So from heads, I can have 2 possible outcomes, which is the second coin, or 2 possible outcomes. So the second coin could be head or tail, and head or tail. So to color code it for you, this is the second coin, and this is the first coin. All right, first, second. So now my possible outcomes are head, head, or head, tail, or tail, head, or tail, tail. So total number of outcomes you can see in the final column is 4. Find the probability of tossing 2 tails. So 2 tails is there, and that is 1 out of the 4 possibles. 1 tail, you can see there is this outcome here which has tail head, and this outcome here which has head tail. So that is 2 out of the possible 4, which is also the same as 1/2. And at least 1 head, we have these 2 have a head, but this one also has at least 1 head, so that is 3 out of the possible 4 outcomes. The last one, tail, tail, didn't have any heads. All right, so there's an example of how to draw it. We split it up into either first round, second round, or first step, second step. If there was a third step, we'd continue on past the end there. This is why tree diagrams are good for multi-step probabilities. All right, so having a look at our final example here, we're going to do a tree diagram without replacement. I'll move it down to here. All right, so it says 2 people are selected at random without replacement from a group of 3, Annabelle, Brodie, and Chris. So we have our first choice could have 3, Annabelle, Brodie, or Chris. The next round, there could be only 2 choices, because once I've chosen Annabelle, I can't choose her again. So each round has only got 2 choices after that. So I could have chosen Annabelle, then Brodie, or Annabelle, then Chris. Brodie, then Annabelle, or Brodie, then Chris, or Chris, then Annabelle, or Chris, then Brodie. So we can see here that our final results are going to be Annabelle, Brodie, Annabelle, Chris, BA, BC, CA, CB. So counting them up, I've got 1, 2, 3, 4, 5, 6 possible outcomes. And the question says to list them. That is them there. All right. The next one says to find the chance the selection will contain Annabelle and Brodie. So I'm looking for anything that has AB. So I've got AB there, but I've also got BA there. So that gives me 2 out of the 6, which is the same as 1 in 3. Find the chance the selection has Chris in it. So any of the answers that have Chris. So there's 1 there, 1 there, 1 there, and 1 there. So that's 4 out of the 6, which is the same as 2 in 3. And then it says Chris or Brodie. So now I'm looking for any answers that have a C or a B. So I've already got the 4 because these 4 have Chris in them. The ones I didn't have had B in both. So that means that my chances of choosing Chris or Brodie are 6 in 6. All right, so that I have a 100% chance of choosing either Chris or Brodie. And that makes sense because Annabelle is only 1 choice, and the other choice has to be either Brodie or Chris. It can't be 2 Annabelles. All right, so to recap, going back, tree diagrams will show multi-steps or 2 or more steps. The steps go across the page and the outcomes are listed vertically at the very end. All right, when we have it without replacement, we look at the previous result and we exclude that from the next round of results. Looking at using probabilities, we have to count up how many outcomes we have. That will become the denominator in the fraction we use to express the possibility. All right, so now that you've learned all about that, have a go yourself and let me know if you need any help.